Okay, students, we're going to do a quick review of topic 1. These are the main concepts that are in there and on your test as well. Okay, first one, they're going to give you an equation that says, such as this, x equals 4, graphed for you, x equals negative 4, graphed for you. And they're going to say, here's a point 1, 3, draw a line parallel to it. So you plot 1, 3 right there. Draw a line parallel to it right there. Okay, they want to say, you know what parallel means. To another parallel, to another vertical line is another vertical. And B would say, now through the point negative 4, negative 2, which is right here, draw a perpendicular to it. So obviously that's horizontal. All horizontal are perpendicular to vertical. That's simple. All right, next piece. They're going to give you 2 points, and they'll say, write a parallel line to that, through that line of those 2 points that goes through negative 1, 4. Well, you should know when you see parallel that you know the 2 words are same slope. So I need to find the slope. You're changing y over changing x. You've been doing that 8th grade, 9th grade, and now in geometry, 10th grade. Okay, so subtract your y's, go in the same direction. You should draw an arrow, 9 minus 3, 6. Subtract your x's in the same direction. Doesn't matter if you go left to right or right to left, as long as they're both in the same direction. These are all this stuff that we're talking about here is also on that video on the algebra review. Okay, a lot of this stuff is there with this equation of lines. Okay, that's on there. And doing slope. Okay, so you can see a lot more examples with that as well. All right, so you get 6 over 4, but we know you must reduce always. So it goes down to 3 halves. And parallel means same slope. So now I have that slope. And now I just have to fill it into the point slope form. You should already have point slope form memorized. Y minus y sub 1 equals m times the quantity x minus x sub 1. And we should already know that x sub 1 comma y sub 1 is just the point given to us. And m is your slope that you've known for years with slope-intercept form. So all you have to do is fill it in now. That easy. So there's my x sub 1, y sub 1. Fill that in. Y minus the y coordinate is y minus 4 equals the slope, 3 halves. Fill it in. Times x minus a minus 1 is plus 1. And you're done. So here's your answer. Next, it'll ask you, okay, now do a 1 through that is perpendicular through those 2 points. That goes to the point 3, negative 6. The only difference between these two is the word perpendicular. Perpendicular, you should already know, is negative reciprocal. You said that at least 20 times in your class. Okay, and so the negative reciprocal of 3 halves is negative 2/3. So now I just replace that in for the slope, and I use the point 3, negative 6. So y minus the y coordinate, y minus negative 6 is plus 6, equals the slope, negative 2/3 times x minus the x coordinate 3. That's simple. Should be easy. Plugging it right in. You should already know point slope form inside and out. Okay, it did not save. Let me make sure. Yep, okay, so it didn't save the next one. All right, so next, the key that we're going to do that covers the majority of it. Come on, put it on the screen. What is this not coming on the screen? Okay, so now they give us a triangle, and this could be with a quadrilateral or a trapezoid. Okay, I'm just doing it with a triangle. It's the same steps over and over again. We did it the last 2 sections of it. They're going to ask you to find slope of each side. So if I call this A, B, and C, so I got to find the slope of segment AB, slope of segment BC, and slope of segment AC. Okay, and we know anytime they're asking for slope, that we're going to draw a right triangle. So we got right triangles drawn all around this. Okay. If I go from C to A, I'm going up 1, 2, 3, 4, 5, 6. So it's plus 6 and right 2. From A to B, I'm going 1, 2, 3, 4, 5, plus 5, and I'm going down 1, 2, 3, 4. From B to C, I'm going down 2, and I'm going left 1, 2, 3, 4, 5, 6, 7. Okay, so now we know every time slope is changing y over changing x. So from A to B, changing y is negative 4, changing x is 5, and that should make sense. It's a negative slope. BC, I have changing y, negative 2 over negative 7 makes it positive 2/7, and that makes sense. It's a positive slope. Slope of AC, 6 over 2, which is 3, and that's a positive slope. That makes sense. So it's going to ask you for the slope of each side, then it's going to ask you for the length of each side. So now we have length of AB, length of BC, and length of AC. We already have our right triangles drawn. Every time we have an oblique segment, we know that we're drawing a right triangle, which is already drawn for us here. And we're going to use Pythagorean theorem. So from A to B, we have 5 squared plus negative 4 squared. So 25 plus 16 is 41, square root of 41. From B to C, we have 49 plus 4 is 53, square root of 53. And from C to A, we have 36 plus 4 is 40, square root of 40. Square root of 40 would simplify, but remember, as I told you on the edge elastic, they do not simplify any radicals, so you would just leave all 3 right there. Now, so there's all 3 side lengths. If they ask for the perimeter to the nearest hundredth, I would now just type that in my calculator. Square root of 41 plus square root of 53 plus square root of 40. Put in the calculator. So 41 square root plus 53 square root. Oh, it didn't do it because I was using that. All right, let's try it again. Let me see those numbers again. 41, 40, 41, and 53. Okay, let's put this here. 40 square root. Let's make it 0. Okay, 40 square root plus 41 square root plus 53. Oops. 53 square root equals 13.68 round to the nearest hundredth. They've been asking us to go to the nearest hundredth. So that'd be our perimeter. And remember, I told you on the DCAS and on the edge elastic, if you round incorrectly because you don't know how to round in a hundredth spot, they're going to give you no credit. They expect you to remember that from elementary school on. Okay, and the last piece they're going to ask you is to find the area of that triangle. Okay, and of course, we did this in the last lesson of the unit where we have our rectangle drawn around it, which there it is already. And we find the area of that rectangle. So now we're doing area of the triangle. So we do the area of the rectangle. So we do the rectangle around it. So that is 6 times 7, which is 42. Let's move it down here a little bit here. So we have 42 for the area of the rectangle minus, I'll call that one rectangle 1, rectangle 2, and rectangle 3. So minus the area of, triangle 1, 2, and 3. Triangle 1. We know area of a triangle is 1/2 base times the height, so half of 2 is 1 times 6 is 6. Minus area of triangle 2. Half of 4 is 2 times 5 is 10. Minus area of triangle 3. Half of 2 is 1 times 7 is 7. Okay, so we just do that basic calculation. 42 minus 10 is 32. Minus 6 is 26. Minus 7 is 19. Okay, square units, but of course on the DCAS and the edge elastic, you can only put the number in. So our answer would be 19. Okay, so this right here covers the majority of everything that's in our topic 1. It could be, instead of a triangle like this, it could be with a quadrilateral, it could be trapezoid. Then don't forget you have it with a composite figure as well. We did it with a composite figure. Remember, anytime you have horizontal or vertical segments, you count them. And every time it's an oblique one, just like all three of these here are oblique, we had to draw a right triangle and use Pythagorean theorem. Okay? Remember, if it's a composite figure, you can go ahead and divide it into pieces on the inside. Let's just say I had this shape right here for my composite figure. Let's say that was my composite figure. Pretty basic. I could go ahead and cut that off right there. And I have 3 by 3 square there, so that's 9 square units. And 1 by 1 there, and that's a triangle, so it's 1/2, 1 times 1. So half of 1 is 0.5. So that area would be 0.5. And so for this composite figure, the area would be 9 plus that 0.5 for a total of 9.5 square units for that area. So I can go ahead and break that composite figure up into shapes I know, either squares, rectangles, or triangles. Find the area of each one and add it together. Okay. Don't forget you need to know your shapes of all your quadrilaterals, and you should know their definitions. So I'm going to ask you to justify why this is a trapezoid. You know the definition of trapezoid is at least one pair of parallel sides. So I must show that a pair of sides is parallel by finding the slope of each side. Okay, or as a parallelogram, both pairs of opposite sides are parallel, so I have to find the slope of both pairs of opposite sides and show that their slopes are exactly the same. Remember, we can show that two segments are perpendicular, such as for a rectangle or a square, to show they're 90 degrees perpendicular by finding two consecutive sides and showing that their slopes are negative reciprocals, because you should know perpendicular automatically means 90 degrees, right angle, perpendicular, negative reciprocal. And negative reciprocals deal with their slopes. So I need to calculate their slopes. All of this is done multiple times in your book. We did it in class multiple times, so you should be able to look any of these things up for your lessons. Okay, so then you have your skills book that I've sent you that you can do more practice problems of any of these. You have your now 2 practice tests. Okay, I already graded the one, gave it back to you where most of you didn't show work, so you got a poor score on it. You should go back and do it and show the work on it like I have right here. I should see the same type of stuff right here. Your right triangle is drawn with your lengths around them, just like this, or you're doing your slopes, and you can use the same thing for your Pythagorean theorem. This is what I should be seeing. Okay. Um, so this is all the key. You got to know the slope of each side, the length of each side, and then adding those lengths up for perimeter and find the area by drawing a rectangle around it and subtracting off the triangles that are outside the shape. Or if it's a composite figure, like we just did down here, we can break that shape into different shapes on the inside. In this case, I had a square and a triangle to add together. Find the area of each one. So if you can do this, and like I said, the last 2 pages, find the slope and do a parallel and perpendicular. No, parallel is same slope, perpendicular is negative reciprocal. You better know your point slope form. Okay, then you can always distribute that through. So if I was to distribute this through here, okay, I have negative 2/3 x. The 3's cancel, the negatives become a positive, it's plus 2. And then subtract that 6 across, minus 6. So that final answer becomes y equals negative 2/3 x. 2 minus 6 is negative 4. Okay, and so they want to see something like that on there. Okay, in slope-intercept form on the edge elastic. If I did that same one for this right here, okay, I have y equals 3/2 x plus 3/2, and then I'm adding 4, and 4 is 8/2 because 4 times 2 is 8. So now combine like terms, I get y equals 3/2 x plus 11/2. And there's my equation in slope-intercept form from point slope form. Okay, and back to the first page again, parallel, same, and perpendicular of a horizontal is vertical, or perpendicular of a horizontal is vertical. Okay, gotta be all plot points and no parallel same slope, perpendicular negative reciprocal. All right, that covers it, 15 minutes.